Alright, so we're going to divide radicals. We're going to simplify division of radicals, and we're going to try and use this idea as much as we can by either separating and conquering or combining and conquering, because sometimes we can separate these into this fraction into things that can be more easily simplified, but sometimes we can combine. So if we separate and conquer, we'd first take a look at our fraction here and say, you know what, I can't simplify my fraction, so let's separate and conquer. We can also, though, try to combine and conquer, something like this. Well, you know what, I could kind of maybe simplify this, but you know what, it might be easier just to combine it, cancel out the y squared over y, and now we've got something like 7 square root of 7y squared, which can be simplified a little easier. So we can separate and conquer and combine and conquer, but sometimes we can't separate and conquer or combine and conquer, because if we take a look at this, well, if we could separate it, well, it wouldn't really help us because the square root of 2 can't be simplified. So what we have to do for something like this, if we've got this, and again, this violates rule number, I think, 3 back there when we had the simplification rules. We can't have a radical in the denominator. Way back when, I think people said, you know what, if I'm going to divide by something, I want to divide by something that's a whole number, because square root of 2, remember we said was 1.414, etc., and it went on forever and ever. And if you're going to divide by something, you want to divide by something that's a whole number, let's say. So how do we get that whole number? What we do is, if we've got a square root of 2 in the denominator, we have to multiply by square root of 2 over square root of 2. And in the green, we're really multiplying by 1, aren't we? Square root of 2 divided by square root of 2 is just 1. But when this happens, when we multiply by square root of 2 over square root of 2, the numerator becomes 2 times square root of 2, 2 square root of 2. Denominator becomes square root of 2 times square root of 2, or square root of 2 times 2, or square root of 4, or 2. And what happens is we get rid of that square root, or the radical, in the denominator, and that's called rationalizing the denominator, making it rational, make it think right. So after we rationalize the denominator, now we take a look at simplifying. 2 divided by 2 is 1, so we get just simply square root 2. And that would be our answer. All right, how do we rationalize this? Number 5. 3 over square root 5, well, we can't have a square root in the bottom. Can't have a square root in the denominator, so we multiply by square root of 5 over square root of 5. Numerator becomes 3 square root 5 over square root 5 times square root 5 is square root of 25, or 5. And 3 and 5 can't cancel, reduce, or simplify, or factor out, so there's our answer. Square root of 5 divided by 5, the 5's don't cancel because they're not the same. This is a square root of 5, that's a 5. And we're done. All right, make things a little bit more complicated. Let's take a look at this guy. 14 square root of w over square root 7. You know what? We can have a square root in the numerator, but the denominator can't have it. Multiply by square root of 7 over square root 7. What do we get? 14 times square root of w times square root of 7. 14 times square root of 7w over square root 7 times square root 7 is square root of 49, or 7. And now 14 and 7 cancel to give me just 2. 14 divided by 7 is 2. Square root 7w doesn't cancel, factor out, or simplify. 7w can't be simplified inside the square root, so we're done. All right, over here, what do we got? Square root of 3 in the bottom, in the denominator. Can't have it. Multiply by square root 3 over square root 3. What do we have? 6y square root 3 over square root of 3 times square root of 3, 3. 6 and 3 can simplify to 2y square root 3. Done. How about this guy? Well, let's see. Square root w over square root 12. Let's see. Let's separate and conquer. First of all, can we cancel w and 12? No. So let's do square root w over square root 12. let's multiply by square root 12 over square root 12. What do we get? Square root w times square root 12, square root 12w over square root 12 times square root 12 is 12. This guy can be simplified though, so let's take a look. I'm going to extend my page. Get some more room. I've got square root 12 square root w as my numerator. Square root 4 square root 3. I'm going to simplify my numerator here and then put it over the denominator. Square root 12 is square root 4 times square root 3. Square root w is square root w. I've got 2 square root 3w. And that square root 12w became my numerator of 2 square root 3w over 12, or simplified to square root 3w over 6. And I'm done. And all we did was separate and conquer, multiply by the square root 12 over square root 12, and the only problem is that the square root 12 can be simplified. We could have simplified it down here and multiplied by a square root 3 over square root 3 to get our square root 3 in the top, but either way, we combined, we rewrote our numerator and rewrote it here, and then we simplified our 2 over 12 to get 1 over 6, or just invisible 1 over 6. Alright, same idea is going to hold true over here. We're going to have equals square root z. First thought is we cannot simplify the z over 18, so we give everybody their own house. Multiply by square root 18 over square root 18. We get square root 18z over, 18. And now 18, let's do the same thing over here. Square root 18z is square root 18, square root z, square root 9, square root 2, square root z. That's a 2, that's a z. 3 square root 2z. And that's square root of 18z is simplified as 3 square root 2z. 3 square root 2z over 18 gives me square root 2z over 6. The 3 and the 18 cancel out. Cancel, factor out, reduce, simplify. Same answer. Square root 2z over 6.